Hello and welcome. My name is Laura Cosio, and I'm a doctoral researcher at the Gamification Group at Tampere University in Finland. I will be presenting our paper, Virtual and Augmented Reality for Environmental Sustainability, a systematic review. This project has been funded thanks to the Academy of Finland's Unite flagship. Engaging individuals in environmental issues can be challenging due to a lack of understanding and other factors that impede public action. Environmental changes are complex and abstract subjects to communicate, making it challenging to motivate action from political leaders and individuals alike. Identifying barriers to public action highlights the issue's multifaceted nature. In the last couple of years, there has been a noticeable increase in interest in XR technology in both the industrial and academic sectors. Its ability to create first-person participatory experiences for users and immerse them, either partially or fully, into new realities has sparked the imagination of many, including those working in environmental sustainability, for the potential such technology can hold to benefit areas such as physical, cognitive, and social-emotional development. As XR is still a new technology, we need to understand how to best use it for environmental sustainability. We conducted a systematic literature review to analyze the design of the applications, methodologies, and their effect on users. This review contributes to the field by providing a comprehensive overview of the use of XR for environmental sustainability, and by providing a theoretical, thematic, and methodological agenda for future research. We conducted a systematic literature review based on PRISMA guidelines using a search string that covered the variety of XR technologies and their associated names, as well as keywords that were related to climate and nature. A database search through Scopus resulted in 1,736 articles, which we reduced to 80 through a two-step abstract and full-text screening. We then coded the articles along different categories to identify bibliometric data, domain areas, XR technology used, the XR application's features, research methods, study participants, and reported outcomes of the studies. So what were the results of our analysis? Before 2018, there were only a few papers published each year either using AR or VR technology related to environmental topics. However, from 2018 to our cutoff of February 2022, the literature referencing the use of VR in their search rapidly increased. Due to that increase, VR was the most widely used XR technology in both empirical and non-empirical papers within our analysis, with only a small percentage of papers referencing the use of AR. Among the empirical papers, we found that studies using VR mainly recruited adult participants, while the studies using AR mainly focused on elementary school participants. Many of these studies were also identified to fall within the domain of education and learning, with the domain of environmental and ecological behavior also having a high percentage. As for the non-empirical papers, a vast majority did not identify a target audience for the XR applications, but similarly had a large focus in the domain of education and learning. Other identified domain areas in the papers were crowdsourcing, decision-making, environmental awareness, connection with nature, and training. Through both empirical and non-empirical papers, we identified 31 unique features, which we organized into game elements, immersive elements, and types of user interaction. In line with the number of papers falling into the education learning domain, aiding in learning was a common reasoning for the implementation of certain features, although aiding embodiment and awareness were also mentioned. However, we also noted that many authors provided minimal or no explanation for their purpose, which could be identified in the paper. While analyzing the literature, we noted that papers dealing with VR came in two varieties, those which included interactive elements and those which provided users with 360-degree video experiences. As these can provide very different experiences for the user, we analyzed these two conditions separately in the results of the empirical studies. Outcome variables related to learning and knowledge acquisition were the most frequently referenced measure variables among studies using AR or VR applications with interaction. However, VR using 360-degree video, environmental inclination and behavior was the most common measured outcome variable, with outcome variables related to learning and knowledge acquisition being the second most measured. Only a small percentage of papers analyze relationships between measured outcome variables, and only a few studies contain comparative studies. Among both, a majority were using the 360-degree video conditions. Additionally, many studies use questionnaires as the sole data gathering method, but use different assessment instruments. This, in combination with the varying context that measured outcomes were being measured in, creates difficulties in identifying and documenting the benefits of XR use in environmental sustainability with certainty. These findings suggest that while there has been significant growth in the use of XR technologies in environmental sustainability research, there are still many areas that require further investigation. We, therefore, developed 8 suggestions for future research in the field based on our findings. One important direction for future research on XR and environmental sustainability is to expand the thematic focus beyond education and learning. Specifically, studies should explore how XR can be used to increase individuals' sense of self-efficacy and their perceived locus of control over environmental problems, ultimately promoting pro-environmental behavior and a connection with nature. Another thing to consider is also diversifying the intended purpose of implemented XR features in the field of environmental sustainability. By studying the impact of these features on measured outcome variables beyond learning and knowledge acquisition, we can gain a better understanding of the potential benefits and limitations of XR interventions. In addition, researchers should continue to leverage the technology's known strengths, such as exploratory and participatory experiences, while addressing its limitations, such as difficulties in concentration. Further studies can also aim to better understand how users interact with the technology. To ensure that XR interventions are effective across different populations, future research should explore the impact of users' personalities, personal attributes, and the age on the efficacy of XR interventions. As with any emerging technology, it is essential to also investigate the potential long-term consequences and ethical aspects of XR use. Future research should therefore address these concerns to ensure the ethical and responsible use of XR in this field. To enhance consistency among validated measurement instruments in XR studies, future research in environmental sustainability should aim to use a standardized set of tools to measure outcomes. Moreover, researchers should investigate the associated effects between measured outcome variables such as spatial presence and behavioral intentions, or interaction and learning. Incorporating objective and subjective data can provide a more comprehensive understanding of XR's influence in environmental sustainability. Although questionnaires have their strength, researchers should strive to also incorporate other measurement methods to supplement self-reported data. To aid in research and the development of environmental sustainability, research should also strive in the future to perform more comparative studies between interactive XR applications and other mediums. This can include comparing the effectiveness of XR applications with traditional educational methods, or examining the impact of different types of XR technologies, for example VR versus AR, on users' behavior and attitude towards environmental sustainability. Thank you for your time. If you have any questions, please feel free to reach out, and keep an eye out for other gamification group papers present this year at CHI 2023.